Hello everyone, and welcome back to another video of competitive programming. Today we'll be taking a look at the British Informatics Olympiad paper, and we'll be looking at the 2019 paper and the first version for it. So let's just have a look at it. So the question is quite short actually, but it's not an easy question. The question basically asks you to print the next palindromic number which exists upon a certain input. So I'm assuming you guys know what a palindromic number is, but if not, the definition is quite simple. It's just any number which is the same as the one where its reversed number is the same as it. So for example, let's say like 1, 2, 3, its reverse is 3, 2, 1, but 1, 2, 3 is not the same as 3, 2, 1, hence they're not palindromic. Something like 1, 2, 1 would be reversed to 1, 2, 1, so it's palindromic. So let's just have a look at the solution to the code before we look at the actual code itself. So one thing which you guys may have noticed from the question, which you should have noticed to be honest, is that they can give you an input of up to 20 digits long. So a brute force solution would just be, let's just say that this is the input 1, 2, 3, 4, 5, and we want the next palindromic number after 1, 2, 3, 4, 5. So then what we do is that we iterate through each number, we keep on adding 1, so we go 1, 2, 3, 4, 6, 1, 2, 3, 4, 7, so on. For each of these numbers we convert them to strings, and then we check whether the string is the same as its reverse string. So in Python, to reverse a string, what we can basically do is colon, colon, minus 1. It's basically reverses a string, hence if the string is the same as its colon, colon, minus 1, then they're the same, right? Because the reverse is equivalent to the original one. However, this is incredibly slow. Like, if you imagine how long it would take, like, even for a 5-digit number, which isn't even the largest they can give you, it would take all the way from, like, the next palindromic number after 1, 2, 3, 4, 5 is going to probably be 1, 2, 4, 2, 1, I think. Maybe 1, 3, 3. No, yeah, 1, 2, 4, 2, 1 will be the next one. So then you would need to iterate through 100 numbers in this brute force approach just to get to this number. And this is only 5 digits. Like, you can imagine if I added 20 more digits, or 15 more digits onto this, 6, 7, 4, 3, 2, 5, 4, 8, so on, so on. You would need to iterate through thousands, and not even thousands, like millions, even billions of numbers, just to get to the next one, which clearly isn't possible in 1 second, and it's really not that efficient. So now I'll be talking about how I tackle this problem and what the optimal code is. So let's go back to our starting number 1, 2, 3, 4, 5. So pretty much we know from definition that the definition of a palindromic number is that if its left side is equal to its right side, basically, like, consider this to be the left part and this to be the right part. If both of them are the same, then the number is palindromic, right? And now, since it's an odd number, the middle number will always be the same in the reversed string, okay? And because, like, consider we reverse the string, we basically have this. 3 remains in the same place, hence we can pretty much just ignore it in our calculations. So then we just need to make 1, 2 equal to 4, 5, or vice versa, 4, 5 equal to 1, 2. In some way, we need to do this. Oh, you need to get the root of that. Anyways, so let's just go over the code of how to do this. So we know that the next palindromic number after 1, 2, 3, 4, 5 will basically have the same left part as this. So the middle digit will remain the same since there's an odd number of digits. We'll come to the case where there's an even number of digits. That turns out to be simpler, but we'll leave that for now. And we know that the right-hand side has to also be this. The left-hand side also has to be this. So therefore, this can just be our new number. And the reason why I reverse these digits is because it's palindrome, right? It has to be the opposite. It has to be the reverse of these 2 digits. Now you might be thinking, well, this clearly is not the next palindromic number after this. since this number 1, 2, 3, 2, 1 is less than 1, 2, 3, 4, 5. So how do we go about doing it now? Because we found a palindromic number which is close to 1, 2, 3, 4, 5, but it's not necessarily the next one, right? So this is where things get a bit more interesting. We need to basically increment this left portion for it to be the next palindromic number. So the next palindromic number would basically be this, like by inspection, right? Since it's a bit difficult to explain, but palindromic number has to be the same as the rest of its digits, and the one which is the next, the largest one after this, will be slightly larger than 1, 2, 3, 2, 1. For a number to be slightly larger than this and a palindrome, this left portion has to be incremented by 1 to become 1, 3. And then this right portion will just be the inverse of this, okay? And obviously the middle digit remains the same. And now if we see 1, 3, 3, 1, this is basically an inverse. Sorry, this one is the next palindromic number after this. So now let's formalize and generalize our algorithm to make it work for any length integer of pretty much anything. So consider the substring A, B, C, D maybe has a center like at F, and then it goes on for a few more digits. We basically need to take the first m digits, where m is the midpoint. We need to take the first m digits, okay? So in this case, f is the midpoint. We're assuming that this is odd. We'll take every digit apart from f. Now, if this will be even, let's just add another f here. We'll basically be taking this f as well inside our thing. And I'll come to how we'll implement this code later. But this m will be the midpoint of it. We need to take these first m digits. This basically becomes an integer, right? Since even though we're dealing with it, we're assuming that this is a string, but it's a string of digits. We can convert them back to an integer. Now, what we need to do is we need to increment this by 1, so m plus plus, until we reach the point where the new number, the new number m, followed by the middle digit, let's say f, and followed by the reverse of m, where this particular string is basically the next palindromic number after this, where this particular string is greater than this input string, okay? Since we know that every string we generate is a palindrome, so we don't need to check that condition, but it has to be larger than the input string as required by the question. I know that was probably a bit confusing, it was a lot to take in, but it will all make much more sense if we just go to the code. So pretty much this code says that we initially accept a string as input, and this part 1, I know this looks like a usual thing, but it's not that scary. But remember how I explained back in the whiteboard that every digit up until the middle digit, and the middle digit will be included if it's an even length substring, and it won't be included if it's an odd length substring, should be in part 1. Okay, so the way we do that in Python is we get the length, we add 1, and then we do the absolute division by 2. The way this absolute division works is that it ignores any remainder, so like 7 / 2 would give 3. Since 2 goes into 7 3 whole times, and we just ignore that remainder 1. So we basically get the first 3 digits, which will be index 0, 1, and 2, which will then be in part 1. Okay? Now, we basically have this while loop. While true, what we'll be doing is we'll be incrementing part 1 by 1. So remember, as I explained, the next palindromic number, which will basically be the left side of the string, added 1, because that'll be the next consecutive palindromic number from it. Now we'll be adding 1 to part 1. And now I'll go into detail what these 2 lines do, but for now I'll just tell you that they basically make both sides of the output string the same. So it makes the output string part 1 plus the reverse part 1 if it's even length, if mod 2 equals 0. And if it's odd length, then we basically make part 1, since part 1 will contain f, f being the middle element, right? So it will be part 1 plus the reverse of part 1, every element of the reverse of part 1, apart from the final element, right? Sorry, the first element. Since the first element in the reverse string will be the repeat. So sorry, that was a bit unclear. I'll just explain it over here. Let's say we have the case 1, 2, 3, 4, 5 again. So 1, 2, 3 will be part 1. Okay. And now, to generate the next palindromic, we need to reverse these digits, but then this produces a 6-digit number, right? So then we take all of the strings from, all the characters from the first string, and then we take every character from the reverse string, apart from the first one. So how this would look like in Python would basically be P1 reversed, colon, minus 1, that's reversed. And if we want to have this, if this 1 wouldn't exist, it would just be like this basically, then we would have the entire string reversed, and 1, 2, 3, 4, 5 would become 1, 2, 3, 3, 2, 1. But then with this, it basically ensures that every digit, apart from the first digit, in the reverse string will be added to the output. So this is basically how we generate the next palindromic substring. And then after that, we check whether the integer version of this output string is greater than the integer version of the string which we have as input. Since, remember, if we go back to the question basically tells us that we need to output the smallest palindromic number that is higher than the input. So if we look at the sample 1, 2, basically 3, 4, 3 is a palindrome, but we need to do the smallest one which is higher than the input. Which is why it's strictly greater than, it's not just like loosely greater than, as this would be, strictly greater than. If the integer of the output is strictly greater than, then we basically break. Otherwise, we continue in this loop. And now, a particular case where things get quite interesting is, let's say if in our string or in our input we were given this particular substring, 1, 2, 9, 2, 3. So then our algorithm would initially generate this particular substring. This is less than the input one. Hence we would have to increment this 1, 3, 9, 2, 1. And then that would basically be 1, 3, 9, 3, I'm sorry, which would be greater. This works fine since there's no 9 in here. However, if instead of this we would have 1, 9, 2, and then like 3, 1 or whatever, then our algorithm will produce this as the next one. And let's just assume that maybe instead of this, I make this 9, 2. So this is less than this, hence we need to increment it one more time. So then it will basically go to this. And now the beauty of using numbers over here is that we can increment it as normal and it'll produce the next one. We don't have to worry about units, digit, or anything. Had we treated these as strings, we would have had to increment each one individually, which would have been a pain. But treating them as integers over here is much more convenient. So as you can see, this question has a lot of switching between strings and integers, since each one has its own uses in this question. And that's pretty much the entire code. And we basically continue iterating and generating our substring until the integer version of the output string is greater than the integer version of the input string, at which point we break and finally print the output. So let's just see this code. So if we have 3, 4, 3, it will basically work. And if we just go to the some of the larger test cases, I hope you guys appreciate the importance of us doing all this rather than just having a brute force code, because consider some of the numbers here, like let's just consider this thing. This number is probably 18 digits long. Brute force code will not work here, right? So now let's just go back to the program. And it pretty much output instantly, right? And as you can see, this particular substring, if we go back to the mark scheme, they're basically identical. It's the first 9 digits and then the first 9 digits reversed. And now let's test on another one. Maybe we'll test on the final one over here. And now let's go back to our program. Again, it basically outputs instantly. And we have 98765432220. And then we have 22345, again what we just had. Now if we go back to the question, it's the same, 98765432220, and then 223456, so on and so forth. So that was pretty much it for this particular video. This was a really enjoyable question to code and also explain. So I hope you enjoyed something from this particular palindromic sequence question, and I hope to see you in another video. Thank you very much for watching. Bye.